Okay, so for the second video in scientific notation, we're now going to look at some examples of converting the other way around. So if we start with scientific notation and want to convert to whole large numbers or small numbers. So let's look at the first one. Write 7.8 times 10 to the 12th as a whole number. Okay, so the way you do this is kind of similar as to the way we wrote it in the first place. We know if we're moving 12 places and it starts after 7, that it's going to be a 13-digit number. So just keep that in mind. So we're going to write the 7 and the 8. And then we know we need, because this is 12, it's a 13-digit number, the 8 counts as one of them, so we know we're going to need 11 more zeros. So let's just do that out. Alright, and what I'm going to do is check. So if I take my arrow and I start between the 7 and the 8, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what we need. Whoops. Okay, so then we just carefully put our commas in where they're appropriate after every 3 digits. Okay, so there it is. 7,800,000,000,000, I believe. Okay, the next one, do the same thing. So 2.4 times 10 to the 6th, it's like going 6 places from the decimal. So if off to the side you want to write it this way to figure it out, you can. 1, 2, 3, 4, 5, 6. And just fill in the little loops here with zeros. Alright, so that's my answer. I'm just going to write it a little bit more formal over here. 2,400,000. Okay. Let's look at a small number. Notice the negative exponent tells us it's a small number. So remember with this one we're going the other way, we're going to the left. So we'll take the decimal point, we'll move 5 units to the left. 1, 2, 3, 4, 5. New decimals there. So we're going to be dealing with, I always put a 0 in the front, 0.0000043. Okay. Take a look at the next slide. So we have some examples that I'd like you guys to try based on the notes from the first and this second video. So if you want to pause it, come back to this, then we'll move on to the last piece. So go ahead and try these out. Okay. Looking at the last piece, products and quotients in scientific notation. So we can take scientific notation and do other math with it as well, similar to what we've done with our exponents in this chapter. So for this last slide, I'm just going to show an example of multiplication and an example of division here and here, and then I'd like you guys to try the two on the right. So start off with the first one. So we know when we're multiplying exponents with like bases, we add the exponents. But when we're multiplying just regular numbers, we just multiply them as if they were numbers. So it's kind of like you're dealing with the number stuff and the exponent stuff separately. All right. So 3.2 times 10 to the third times 2 times 10 to the second would be 3.2 times 2, okay, times whatever 10 to the third times 10 squared is. So that should be 10 to the 3 plus 2, according to our properties. That's going to give us 6.4 times 10 to the 5th power. Alright, let's look at the bottom. Division works the same way. We divide the first numbers, we divide the second numbers. So 6.4 divided by 2 times 10 to the 84 minus 2, division means minus, is going to give us 3.2 times 10 to the 82nd power. Okay, so let's see if you guys can try these two. And afterwards, you could try the practice handout for some extra practice.